you struggling with math? Know that there must be a better way to study, but haven't found it yet? In this video, I'm going to share 10 very specific math study tips you can put into practice right away to learn math much more effectively. I am a Harvard Applied Math graduate who frankly struggled mightily my first year. To try and turn things around, I experimented extensively and researched the theory of how to learn. Applying the methods we're going to go through, coupled with hard work, I was able to graduate with honors. I want to share these methods with you since they are likely to help you too. These are the things I wish I knew when I started struggling with math for the first time. Let's get started. When working on problems, how hard should the problems be, and how long should you work before getting help or looking at the solution? Studying math, like anything you want to learn, is most effective when you are following a method called deliberate practice. This means you don't waste time solving lots of problems that are easy for you, but you also don't spend days on problems that are out of your reach. Some mathematicians advise to never look at the solution to problems because it takes away an opportunity for learning. I agree with the spirit of this advice, but in practice, I have found that it's definitely not true. Finding the sweet spot of problem difficulty will make all the difference in accelerating your learning. When working on problems, you definitely don't want to try for 30 seconds and then look up the solution if you can't figure it out immediately. To really learn math, you need to learn to struggle. You need to learn to be lost. But it isn't helpful to spend days on a single problem or start to feel helpless. As a rule of thumb, 20 to 30 minutes can be the right amount of time to work on a tricky problem early on, and this increases with your mathematical maturity. Accept that some things are out of your reach, for now. Build up to harder problems as needed. Optimize for learning efficiency. Learn to struggle for just the right amount of time. Tip number 2 is to rederive results, one line at a time. This is a technique I first heard about from Andrew Ng in the context of machine learning, but it is just as applicable in math. It's a simple idea, but not one that I had really practiced until seeing him suggest it and explain it. What you do is after learning a proof or derivation, you cover it up with a piece of paper. Start at the top and see if you can rederive it, one line at a time. As you go, check each step against the original, slowly sliding the paper down as you go. If you can't move to the next step, uncover the paper, look at the step, and then start over. Repeat until you can reach the bottom. To be clear, I definitely don't recommend rote memorization. Turning a proof or derivation into an outline in your mind is a great skill to develop, and how you want to remember proofs and derivations. But you still need to make sure you can take a proof sketch and turn it into an actual correct and complete proof or derivation. This can and likely will reveal gaps in your technique or understanding that you can then go and address. Tip number 3 is to practice retrospection. After finishing a problem, especially a hard one, it's tempting to shout, "Finally done!" and move on to the next one. If you do, you're missing a golden opportunity to really learn math. If you didn't complete the problem and looked at the solution, or if you did complete it but struggled to find the solution, take time to retrospect. Think about what made the problem hard. Was there some theorem used that you didn't really know about? Maybe a definition you couldn't recall precisely? Some technique that you weren't familiar with or that you hadn't thought of to apply for this problem? Maybe a clever trick you hadn't seen before. Think about it deeply. Write it down. Then go and fill in any gaps you identified. If you really want to take it to the next level, go find another similar problem and solve that too. This retrospection is where the real learning happens. You are almost sure to see similar problems again in the future, and now you'll be ready. Tip number 4 is to learn how to cheat effectively when working on problems. What do you do when you get truly stuck on a problem? Should you just look at the answer? No. Some great math books have hints when you get stuck. If so, try using just the hint before looking at the solution. If there are only solutions at the back of the book, and the solution is more than just a number, for example, it has an argument or a proof, try peeking at just the first line or the first idea. It definitely takes some self-control to not look at the full solution. Try solving the problem again, armed now with just a little bit more information. This method still leaves room for learning and struggling and learning to problem solve, and lets you find your sweet spot for solving a problem at the right level of difficulty for you. The next tip is to work on problems out of context of a chapter or section. Context provides a powerful crutch that isn't always helpful for true learning. If you are working on a problem at the end of a chapter or section called Wilson's theorem, guess what theorem is going to be used to solve most of the problems? Yep, Wilson's theorem. The location of the problem at the end of the chapter is providing you with tremendous context that strongly hints at elements of the solution. It is helpful to work in context for some time, but you need to supplement this with out-of-context learning. For example, if you're learning techniques of integration in calculus, don't stick to just the end of the section called Integration with Partial Fractions, since you know what technique is needed there. Find a set of problems on integration that mix the problems up, requiring an array of techniques. This is sometimes called mixed practice, where previously introduced methods are needed to solve the problems. Recognizing when to apply a technique or theorem is as important as learning the theorem itself, and you need to practice this skill. The next tip is to work on problems with solutions. You should always look for problems with solutions, and the more detailed, the better. Spend time searching for problems with well-explained solutions. It's very much worth the effort. Some books include very brief solutions. Some have no solutions included at all. Don't settle for this. Look for past exams, online materials, other related texts that do have solutions. If they exist for your book, try and get the students' or even instructors' manuals with detailed solutions. This is pure gold. Why? Remember deliberate practice from tip number 1? To make it most successful, you need immediate feedback. You need to know if you are practicing the right way. When you work on problems, you will get stuck. Solutions, especially with explanations, can help you get unstuck. And even if you aren't stuck, you might just be wrong. Many times I was sure I had the right answer, only to check the solution and find, whoops, I must have missed something or fell for the trap. Waiting days to get back graded homework is not very effective. And working on a problem with no way of knowing if you got it right or not is not the best use of your time. Find good solutions and use them. Tip number 7 is to derive the same result multiple ways. Many elementary results have multiple derivations. It's tempting to learn the easiest one or the one that is covered in your textbook and move on. Multiple derivations are extremely illuminating and are a surefire way to push your understanding. For example, the normal equations in linear algebra can be derived geometrically, algebraically, or via calculus. Each is helpful in understanding the equations from a different perspective, and each allows for extensions in different directions. Take the time to learn multiple ways of deriving the same result. Use deliberate practice and focus on the derivation that was hardest for you to understand. Push your understanding as far as you can take it. The next tip is to look for extra problems. Looking for extra problems can sound counterintuitive, but it really works. Learning math is all about solving problems and at the right level for you. Don't stop after you complete the assigned problems from class. Or if you can't solve the assigned problems, find easier ones to help build up to your assigned problems. The best students are invariably the ones that have solved the most problems and the greatest variety of problems. Instead of saying someone is good at math, what we probably should say is, wow, they must have solved a lot of problems. There are many sources of extra problems. You can look at past exams, other books on the same subject, or unassigned homework problems. You want problems that stretch your skills and are just a bit harder than your current level, whatever that may be. Finding extra problems helps you avoid a common mistake, and one that I definitely made, of reading and rereading the same problems and solutions from class again and again. This is not a waste of time, but it's not the most effective way to learn, and you will plateau too early. Learning happens from working on a wide array of problems and helps reinforce what you already know. The next tip is to prepare before class or lecture. A common mistake, assuming you are going to class or lecture, is to attend the class cold. If you make an initial pass of the material beforehand, even if you only take 5 to 10 minutes to look at the section of the text that is going to be covered, you start building a mental model of the overall topic and its structure. It helps provide a mental framework where you can now hang each individual theorem, lemma, or example. It also provides guidance in advance around what is the most important result or theorem. If you do this, you will walk into class having overcome the initial shock of, I have no idea what this is about, and instead digest the lecture thinking, oh, so that is where that fits in, or that's what that really means. And you continue filling in your mental model, as opposed to trying to create one from scratch on the fly. Try it. You'll be surprised how beneficial spending just a few minutes in advance can really be. The 10th and final suggestion is to find a good note-taking system. You should experiment to find a method for taking notes in a way that really works for you. Everyone finds a different system. Maybe yours is very detailed, or maybe you just jot down the crux idea or jot out a mind map. Some people prefer electronic notes, others prefer handwritten. Find what works for you. What you don't want to do is watch a video or read a text or go to class and not write down anything. That is too passive. Writing or typing will force you to think, to be active, and most importantly, to start chunking information and condensing it in a way that works for you. You learn a great deal translating information into the representation that works best for your mind. You want to engage in active learning, and note-taking will help you get there. Remember, math is not a spectator sport. Those are my 10 suggestions for learning math effectively. It isn't necessary to immediately follow all of these tips, but if you pick a few and put them into practice, I'm sure you'll see significant improvements. Enjoy your math journey. If you enjoyed this video, please subscribe or give it a thumbs up to help support my channel. Please leave comments below about which of these suggestions you find most helpful, or any other methods you have found helpful for learning math and think others would benefit from. And thanks so much for watching.